Okay, so we are back continuing off of the previous video. We're just getting close up on that YouTube 10-minute block, and so I wanted to bring it right back to where we were. Okay, so at the very end I said 6.2 joules were lost on the way up, 5.6 joules were lost on the way down of the book. So we're going to say that calculates out to an average force due to friction of 4.6 newtons. Now let's spend some time analyzing this a little bit. If I go here like this, 1.28 meters, and this is 0.525 meters, I'm going to be able to calculate that this angle here, theta, is going to be the sine inverse of opposite over adjacent so it's going to be the sine inverse of 0.525 divided by 1.28. And I'm going to get 22.2 degrees. 24.2. And so now I'm going to say the following. Well, let's go back. We got to do some more here. My mass, I'm going to say weight equals mass times gravity. So my weight is going to be my mass, which was 1.90 kilograms, times gravity, which is 9.81 meters per second squared. So I'm going to say my weight is 18.6 newtons. So I'm going to call that force gravity. Another way of saying weight. So I'm going to come down here and I'm going to say that's force gravity, which is 18.6 newtons. I'm going to come back up here. I'm going to make a triangle. And I'm going to say right here, force normal. Well, my force normal is going to be equal to force gravity cosine theta. So that's going to be 18.6 times cosine 24.2. So my force normal is going to be call it 17 newtons. And I'm going to have this force parallel, which I talked about previously. It's not a real force. This is a dummy force. This force parallel is actually the vector addition of force gravity and force normal. Force gravity is a real force. Force normal is a real force. And if I add this to this, what's left over is this dummy force, force parallel. But I can call it force gravity sine theta. And so I'm going to get 18.6 newtons. And we're going to have sine 24.2 degrees. Force parallel is going to be 18.6 times sine 24.2 7.6 newtons. Okay. Now, let's start analyzing some stuff here, and let's see if we can not avoid going into another a video. I had my force friction is 4.6 newtons, and my force parallel is 7.6 newtons. So, if I'm pulling the book up the incline, I should have to overcome 7.6 newtons going up and 4.6 newtons of friction opposing me. So my force up should be 7.6 newtons plus 4.6 newtons, which is going to be, I can do it in my head, it's going to be 12.2 newtons. Now what I calculated as my force up was what I measured as my force up was 12.5 newtons. So now that adds up. My force down should be 7.6 newtons minus 4.6 newtons, which should be 3 newtons. Now, if I apply that, let's go on to another sheet of paper. Let's do force equals mass times acceleration. So I've got 3 newtons equals 1.9, was that my mass? Yep, 1.90 kilograms times some acceleration. So if everything is working out just right, my acceleration, when I let it go down the ramp, 3 divided by 1.9, I get 1.5, well, I'll call it 1.6 meters per second squared. And every time I do a calculation, we're getting a little bit of error. And so everything is probably not going to be super ultra neat, but we'll see how it ends up. It traveled 1.28 meters down the ramp, and it took 1.2 seconds to do so. Its initial velocity was 0 meters per second. Its acceleration was, we just figured out its acceleration was 1.6 meters per second squared. We already used these to find VF, so I already used the time. To find VF. Back here, I found VF using the time. So I don't want to use time. I want to use this acceleration. So I'm going to have VF squared is equal to VI squared plus 2AX. So VF is going to end up being the square root, that's 0, of 2 times 1.6 meters per second squared times 1.28 meters. VF is going to be equal to square root of 2 times 1.6 times 1.28, and I'm going to end up with 2.0 meters per second. And what I figured out previously by a totally different method was I figured out that the final velocity just using the time was 2.1 meters per second. So everything is all starting to come together, and I've just got one last little thing that I want to wrap up, so I am going to go to a third video on this topic.